So the open loop transformation of the system in the linear model, that is called GP of S. So GP of S consisting of the transformation from this point to this point, and this one is the compensator or the controller, and this is the linearized plant dynamics, and this one is the sensing element. So this is the plan. Here it is. So the open loop transformation of the plant is like this. So it is a non-linear model. So non-linear model, it is actually linearized. That is called small signal analysis. So small signal analysis using it is linearized, and this is the linearized plant transfunction, and this one is the compensator, and this is the feedback element. So the GP after linearizing, it is getting like this transformation. So the GP of S is equation number 18. So you can enter this equation directly, and you will get linear open loop transformation. So this equation number 18 is the linear open loop transformation, and the compensator. The compensator here using PI controller, that is the first part in the compensator, that is a PI controller. So that PI controller is this one, that is Kf into 1 plus Ki divided by S. And next one is roll off. So first order roll off filter and a notch filter. This is the notch filter using. So here hydraulic resonance frequency coming at 36 36.12 hertz. So that should be roll off using a notch filter. So at 36.12, we are applying the hydraulic resonance will happen. So like this, the resonance will happen. So at this frequency, we have to add a notch filter. So notch filter is, it will have a shape like this. So at this particular frequency, only the gain value is like this. Otherwise, it is having a unity gain. So this is called a notch filter. At this notch only, it will filter out. So this frequency is filtered out at the hydraulic resonance, and that is a second order notch filter using. The transformation is like this, and this omega f of divided by S plus omega f of the roll off frequency. So the roll off plus PI plus notch is called the compensator for this system. So the compensator consisting of PI controller, that is a controller using, and the notch filter for hydraulic resonance avoiding, and a roll off filter. So this is called compensator transfer function. Equation number 19 is called compensator transfer function, and this GP of S is called uncompensated open loop transfer function of the system. So you are having a plant dynamics and you are applying some signal here, you will get output here. So you are supplying sinusoidal wave from 0 to infinity, then you will get the Bode response. This is a linear system. So linear Bode you will get. So this Bode is called linear open loop uncompensated Bode response. So if you are adding the compensator here and you are not taking any feedback element, this is called compensated open loop transfer function, and the Bode response is called Bode response of open loop compensated transfer function. So that is the second this question. So first you have to find out uncompensated linear transfer function. Then you have to add the compensator in series. That also in open loop. That is called linear compensated open loop transfer function. So compensator you have to add and plus the plant. So that is the second part, first question. And again you have to add the closed loop transfer function. So you have to find the closed loop compensated transfer function. So compensator you have to add and you have to close the loop and then find out, and then you have to check that minus 3 dB bandwidth is 6.7 Hz and minus 90 bandwidth is 6.6 Hz for the linear model. And then you have to find the gain crossover frequency, phase crossover, phase margin and gain margin. This is the first.
For the closed loop TF, it is unity feedback, right?
EF, this one LVDT, this scale factor demodulator is taken here. And this one is the hydraulic actuator. Okay. And your GP is taken from and this one is your GP and this one is your sensor. So the sensor you have to take here. So this omega D1, this is closing the loop. So you have to use the closed loop transfer function for that. So this one you have to enter first GP and this omega D1 and this thing is coming here and these values you are putting, then you will get the, you have to close the loop. So this transfer function is G means 1 upon G is the closed loop transfer function. Okay. So first you have to do these things and you have to check the values are coming as these things. So I think you are entered this parameter file that I told you last week. This parameter file, these 2 pages parameter file. So the parameter file you are added, then you have to only find out this value you can enter directly in MATLAB and find out the first and second part. And the compensator is like this. And the compensator transfer function is for linear system you have to use this one, and non-linear system you have to use this one. So you have to do these things today, and you have to check these values, first and second. After that we can start non-linear model. So you do first 2 things now itself and check these are coming or not.
Sir, when we take the transfer function GP to the Simulink, what element should we use?
GPA directly can use this expression.
No, sir, I wrote that expression. Now we have to take it into Simulink, right?
Yeah, this
What,
one will work. You are using Simulink. Simulink is not required. This otherwise you have to use this linear model. This linear model now. This model you are using, you will get directly Simulink. This entire things, and only you have to do here is the second order filter you have to add. That second order filter is just, I will explain that now. If you are done these things, everyone is done this.
So we don't need to build this, right?
If you want to build in Simulink, you can do it. It is not an issue. You can do it in MATLAB itself also. So the open loop transfer function of the system is K, and this is the spool valve dynamics. That part is this one, and the LVDT is modulator gain. That is this one, and this GP is coming here. So these all are called open loop transfer function of the system. So either you can do it in MATLAB or in Simulink. So those who are doing in MATLAB, here on algebraic loop will come. Here on algebraic loop, that is this loop is called algebraic loop because there is no delay element is there. So in that case, you have to use a second order filter. That gain should be greater than your system gains. So you normally use 5 times than system frequencies, 5 to 10 times. So in that case, you have to just change this one. So this up to this AP is coming here. Here you have to use a second order filter, and that second order filter so if you are entering GP, then you have to run that code and everything should be in same folder. So here you have to use a second order filter. So how to implement a second order filter? So first lab I told you F is equal to mx double dot plus vx dot plus kx So this can be done using 1 by m. One by s and 1 by s. These things I explained in the first class how to do this one. So like this, you have to implement a second order filter. And the second order filter transfer function the transfer function is omega 1 square upon s square plus 2 theta omega 1 s plus omega 1 square. This one is your transfer function. So this will be some output to input. So how to convert these things into Simulink block? So first of all, you have to add two integrators. And this term 2 theta omega 1, this gain is like this, and omega 1 square. So minus, this one also minus. So this is how the second order filter is implemented. So AP, this AP. So this AP will come here, and you have to remove these things, and then you have to add your system. Transfer function as so after AP, this model will come. After AP will be coming here, and this one will be like this, and here you will get PL dot. So this term you can neglect, this SC you can neglect, because here it is PL dot will be there. So you can take PL dot from here, and it is connected to V0 divided by 2 beta E. So like that you can connect. This is given in this model. So omega 1 square divided by AP, omega 1 square divided by AP, and this is coming here, and 1 by s you are leaving, and 1 by omega 1 square is feedbacking here, and 2 theta omega 1 is feedbacking here, and you will get PL dot here, and that PL dot V0 divided by 2 beta is coming here. So this is how this second order filter is implemented. So you are using in linear model Simulink, you have to use this block there. So this omega 1 square. So the transfer function you are taking, you will get like this only. So this is a forward path. So G upon 1 plus GH you have to take. Again that G upon this G plus 1 plus GH you have to take. Then you will get that transfer function.
So once we have that transfer function, which command in MATLAB gives the Bode response?
A body of that system transformation. The
Okay.
transformation name you have to give, then body response you will give.